Seems like we should get started, so thank you everyone for coming. Today we would like to talk about writing dynamic multi-cluster controllers with Controller-runtime. My name is Marvin Beckers. I am a team lead at Kubermatic.
Yeah, I'm Stefan, working on API server things for a long time. Many of you will have seen me before working at NVIDIA on API server topics, so yeah.
All right, before we get started, I would also like to briefly mention that my part of this work has been made possible by the ipsy project, by the European Union. You might have heard that coming up during this KubeCon, but yeah, really nice to be able to work on cool stuff here. Okay, let's get started. So first of all, let's set the stage. Why are we here? And this room is pretty full, so I think a lot of you are facing the same problem, asking the same questions. So why would you want to reconcile across multiple Kubernetes clusters? We live in a multi-cluster world. I think most people that are running Kubernetes are running more than one Kubernetes cluster, maybe also more than two, maybe also more than three. And the tooling around that is quite sophisticated these days. You have tools like Cluster API. You have also other solutions like vCluster who give you lightweight Kubernetes API servers, and countless others. So I think it's fair to say multi-cluster, or like many clusters, is the standard. But reconciling across that fleet of clusters that you have, it's not trivial. And it's not something that is standardized. And Controller-runtime itself is fairly single cluster in how to use it and the tooling around it. So, but the fact remains that you need to reconcile across many clusters if you have many clusters. And a lot of tools have written solutions around this. So, for example, Cluster API has the cluster cache package, which allows to reconcile against multiple clusters. We at the KCP project, we have a fork of Controller-runtime that added multi-cluster capabilities to it. There's also some older projects, like a multi-cluster controller by Admiralty. And honestly, there are probably countless others out there. Probably all the multi-cluster management solutions have their own implementation. But that's the thing. None of these solutions are widespread. They are not generic. And they are not native to Controller-runtime either. So let's set some more context. Let's take a quick look at scaling models. So how can you scale your controllers? So one of the ways, this is the classical one, is per Kubernetes cluster, you have a controller pod running. Within that cluster, it has a manager, it has a cache, it has a work queue, it has a reconciler. And you run each of this construct for every Kubernetes cluster that you have. Another scaling model would be to have a management cluster and run one controller pod per external cluster that you want to reconcile. So you have one management cluster that's basically kind of the workhorse, and there is a process manager, maybe another operator or a controller that launches controller pods against these Kubernetes clusters that you want to reconcile dynamically. And then there's this model as well. Also, you could have a host cluster, management cluster, and the controller pod here would start multiple managers, so Controller-runtime managers, to reconcile against external Kubernetes clusters that you would want to reconcile against. So these are a couple of the scaling models that we've seen already, but we think that there's a way to make it more generic and to build like a tighter integration with Controller-runtime.
Yeah, so we mentioned the word here already on the slides. So there's a new project we introduced a couple of weeks ago, and this is called multi-cluster runtime, and there's a reason it sounds like Controller-runtime. It's a friendly extension of Controller-runtime, so it's not forking anything. It's just using the primitives of Controller-runtime under the hood, and we will see in a couple of slides how this looks like. The project is hosted in the Kubernetes 6 on GitHub, so you will find it here, so Kubernetes 6 multi-cluster runtime, and it's sponsored and owned by SIG Multicluster, so it's an official SIG project. And what we mainly add to Controller-runtime is adding a provider concept. So there's a concept, a provider can discover or should discover the clusters which the controllers will talk to. And we will see a couple of those providers in a second, and also how you build them. And If you look on the repository, there is a kind of disclaimer in the beginning. It's an experiment. And we are all here, or the talk exists because we want feedback and people trying that out, whether this is a model which is actually useful. The two of us, we have background in KCP, and in KCP we needed something like that, and we were for quite some time worked on such a project, but we realized that there are many, many more use cases, and the provider concept is basically opening that up. We talk about two topologies which are probably common. The most easy one is a uniform reconciler. It's a reconciler which actually doesn't know about clusters. It's not interested in cross-cluster operation. It just does its thing for events from a cluster. It reads from a cluster, it writes to the same cluster. That's why it's uniform. Super simple. If you run an existing reconciler but against n different clusters, that's probably the pattern you will follow. But of course, you can build clusters or imagine not clusters. You can imagine reconcilers which know about the cluster concept, and maybe they have dedicated special clusters like a host cluster, for example, and then some child clusters. A syncer is a typical example. If you sync objects from the left to the right, that's a non-uniform controller. You can also imagine you have a cert manager, and the cert manager has CAs, the issuer, in one cluster, like in a host central location, and it creates certificates for many, many clusters, but it never exposes the credentials or the secrets to create certificates. So there are many examples for that, and we want to support both. And the provider concept is basically attached to the multi-cluster runtime core. So this is a multi-cluster runtime. We will see in action in a second. And there's a provider concept, and you can have multiple different implementations of the provider. So imagine cluster runtime. You could have a cluster runtime controller provider which knows how to find, discover clusters in controller in cluster API. Sorry, in cluster API. You could also imagine a provider for kind or a provider for cloud providers. That's just an interface you have to implement, and we see in a second how this looks like. All right, so this is a picture that Marvin already showed. That's not what we want to do. We want a tighter integration. And the model we follow at the moment is this one. So you have a manager, and we call it a multi-cluster manager. It's basically like the one from Controller Runtime, and we see the interface very soon. Here's the provider. The provider engages clusters when it finds out there's a new one, and it disengages them when a cluster goes away. And here's your reconciler code. Here's the work queue. And you have sources like, basically those which get events from the caches, put them into a work queue, a joint work queue, and then the reconciler does its thing. On this picture, the work queue looks super innocent, but it plays a crucial role, and lots of thought must go into that, how this work queue must look like. You can imagine there might be one cluster here, one cache, which has thousands of events, and the others are pretty silent, but the queue is full because the one cluster exhausts all the capacity of the reconciling process. So you have to think about that. You can imagine even cluster. The cluster concept doesn't mean it's a real physical cluster. You could, for example, build a provider which knows about namespaces, and it uses a different client depending on the namespace you're talking about. So if there are some isolation reasons, or you want audit logs or something like that, which show the tenant something in this direction, this could be also a provider. So the cluster concept is very wide, very generic. It doesn't have to be a real cluster. One special case is the KCP case, where in the background you basically only have one cache, one informer, and the provider simulates whatever the sources need here. So we have workspaces in KCP. A workspace looks like a real Kubernetes cluster to the outside, but they're actually all running in one KCP instance. And if you look on the informer, the watch interface here, there's just one connection to KCP. So it's super efficient to have many, many, many workspaces, thousands if you want. But you have only one cache. Even that could be modeled in this provider concept. All right, so we have seen the topology, the objects, the components, and now let's become more practical, right? See how providers work, how controllers work.
All right, so let's take a look. Is this on?
No.
I keep talking, okay. to build a multi-cluster controller. Okay, yeah, I guess we'll do it this way. Okay, so how to build a multi-cluster controller. So let's take a look at controller runtime first. So if you've ever written a controller, this is probably somewhat familiar to you from your main.go file. You set up a manager. That manager is coming from a package of controller runtime. And, well, you eventually register your controllers with that, your reconcilers with that, and then you start your manager. So far, so good. So with multi-cluster runtime, we have a couple of additions, but they are not too big. So the first thing that you want to look at is the provider. So we instantiate a provider, and in this case, we're using the kind provider. So that is one of the examples that we've built already. And then what you do is you create a multi-cluster manager here. So this is what Stefan already mentioned earlier. And it's fairly similar to a normal, a controller runtime manager, with the difference that you're passing a provider in. So this is where I plug in the kind provider. And I also start the provider at a later part of the code. And this is basically it. This is your controller now being a multi-cluster runtime controller. And even if you don't know what provider to use yet in your controller, you could adopt this already, because if you set the provider to nil, well, then you get the same behavior, the same single cluster behavior that you're getting out of controller runtime as well. So if you don't know yet what provider to use, go with nil. You could already use this. No change really to what you've been doing with controller runtime already. Let's take a look at the reconciler. So the reconciler in controller runtime, you probably have seen this already. Maybe your code looks slightly different, but the gist is there is the builder package from controller runtime. It uses the reconcile package, most notably the request type from that, and you have a reconcile function. And that reconcile function can access the cluster object embedded in the manager to access the client and the cache for the underlying cluster, for the underlying physical Kubernetes cluster. In multi-cluster runtime, we have our own builder package. This builder package is, multi-clusterware. It adds on top of what controller runtime is adding. And we have our own reconcile package. And that reconcile package has also its own request type, which has the controller runtime request type embedded, plus the information about the cluster where this is coming from. So it enriches information that you would also get with controller runtime with multi-cluster runtime. So the main difference in your reconciler function is that previously we had the static cluster coming from the manager, but here we need to dynamically fetch the cluster object, because now we don't know which cluster to use until the request comes into our reconciling pipeline. Basically, we need to dynamically fetch the cluster object from the manager and then use that in the following code. But that's basically it. Like, all of the rest of the code can look exactly the same. This is really important to stress for us. Multi-cluster runtime is not a fork of controller runtime. It's a testament to controller runtime's architecture, and most notably the Go generic support that was added, I think, last year? Something, I don't know exactly. So multi-cluster runtime uses the generic types from controller runtime with the concrete multi-cluster aware types that we are adding in our packages. So not a fork. It's an extension. It's kind of an add-on that you can use on top of controller runtime, or like in conjunction with controller runtime. Yeah, the too long didn't listen is select a provider, kind provider, KCP provider, cluster API provider, switch to the multi-cluster runtime builder and reconcile packages, and dynamically fetch your cluster object, which includes the client, from the manager, and then ideally you're already done. You have a multi-cluster controller. Ta-da.
Yeah, that's...
I think your system working.
It works? I think it works.
Yeah.
Oh, good. Oh,
sorry.
So let's dive a bit into the interfaces, like the Golang interfaces. And we talked about the manager, and we hand waved. It's basically like the normal manager plus some stuff. And here it's a bit more concrete. I didn't put everything here on the slide, but you can imagine, just take all methods of the controller runtime manager and remove everything that the cluster, the embedded cluster, adds to it, like there's a get client in controller runtime. This will not be here because the embedding doesn't exist. But we re-add the get cluster to get access to the cluster by cluster name. And if cluster name is the empty string, it's a host cluster where the controller is running, the multi-cluster aware controller. And you can do, for compatibility reasons, you can also ask for a manager, which is a normal controller runtime manager, but now scoped to one cluster. And the special case, without any error here, when the cluster name is empty again, empty string, then you can get even that manager in one call, and super simple. You can also ask for the provider, which might be nil if you provide nil on the constructor. But you might want to use that provider if you want to create indexes. You can imagine there are many caches, many informers, and if you want an index, there might be clusters being created in the future, right? So a new cluster comes online and it's engaged, and then all your index definitions must be applied to that new cluster object, the new cache. That's why there is a connection to the provider, and the provider has a job to manage indexes as well. The provider interface, that's what you have to implement when you want to write your own provider, so cluster API or the kind provider that Marvin has shown. Super simple. It has a getter again, the same getter we have just seen for getting a cluster by cluster name. And this is, of course, called by reconcilers indirectly. We see in a second how this works, but it might be called often. So don't recreate your cache every time, right? Don't recreate the watches to your clusters all the time, but use some kind of state, some map of caches which are running, and then return the right one for the cluster name. And as I said already, index management. So remember the indexes which must be added, and whenever there's a new cluster coming online, re-add the indexes that the user or the developer of the reconciler wanted. That's all super simple, and you can build providers in 50 lines or something, so not very complex. So this picture we have seen already, and if we now add the methods names here, it's not surprising. Here again, there's the manager. I said there's a get cluster getter. That's the one that Marvin had in the reconciler. The reconciler asked for the get cluster. This call is forwarded here to the provider, to the get functions. The provider returns the cluster. Inversely, when a new cluster goes online and it's discovered, then it's engaged on the manager, so the manager knows about it, and it will manage the sources. So then you can imagine another cache comes here into that list, so it's created, and all the sources which are the watches basically against the caches, they are managed by the manager here, so they are recreated or created for the new cluster, and they then produce events which go into the work queue, and the reconciler just processes events from the new cluster. And inversely, when a cluster goes away, then the provider has to disengage. Disengage is, at the moment, it's a context cancel. Maybe we move it into a disengage function, again, for reasons, but basically that's it. That's the whole technique behind the scenes, what provider and managers do in the multi-cluster context. To sum up, a provider responsibility is to watch changes in the cluster fleet. This is highly specific to which cluster manager, which fleet manager you use. And if there's a new cluster, construct the cache object and the client and put it into the cluster, the controller runtime cluster object. Remember that in some map, so keep track of them, of those clusters. Engage them on the manager, so the manager knows about them. And when it disengages, so when the cluster goes away, cancel the context. That's all what you have to do. Bottlenecks, I promised to talk about the work queue here. You have to think about what is the bottleneck of your reconciler. Now you might have many, many clusters, and you have to think how to organize maybe fair queuing. So if there's one cache which produces tons of events, another one hardly any event, then maybe you want something like individual queues here. And then some fair queuing mechanism which picks events from every of those in a fair manner, so that not one of them can exhaust the capacity. And maybe priority queues will play a role in the same way as in controller runtime. So this thing will depend on where your bottlenecks are. So you can imagine maybe the QPS of the client as a bottleneck, could be. Or maybe you run a heavy scheduler here, which is super CPU heavy, and the CPU of the pod is the bottleneck. Or maybe the workers are the bottleneck. So depending on that, you have to think about what a good queuing strategy is. And I bet here in the room, many will have experiences with that, and also related topics like sharding of controllers. So we are very open for ideas and previous experience to design that. At the moment, this fair queuing only exists as an idea and a very crude implementation. Of course, there's more work necessary, so if you have background in that, very welcome to hear about that. Yeah, and now let's go to the demo, I would say.
All right, let's see if I can do that this way, but let's have a quick look at how this works. Like, let me show you a small little controller that I wrote. It's an extension of the code that we've seen before, and let me show you. Let me show you this running against KCP. So we start with KCP first. So this controller that I've written, it just looks for config maps. And when it finds config maps in the KCP instance, then it will log a line. Simplest reconciler you could write, to be honest, because it doesn't do anything. So something that you can see from the logs here already is that we have the cluster name. And I'm not sure if should be fine. The cluster names are in here in the log line. So each of these reconciles that you see here, they come from a different cluster, so from a different source than what you've seen in the diagrams before. And all of them are actually reconciling this config map with the same name, which is the kuberoot CA cert, but it's different instances of that object because they come from different clusters. So how difficult would it be to switch this controller now to use the kind provider, which we've talked about before? So let me quickly show you something. Namely, me typing. Thank you very much. So, all right, got it. OK, so this is basically all the changes that I need to do when I want to switch providers. So I import a different provider. I set it up instead of the previous KCP provider that I've been using, and I'm done. So if I now check, all good, all good. If I check this out now, and it's of course the wrong checkout commit. So let's see, should be this one. Perfect. So now I'm using the kind provider, the changes that you've seen, and I do a go run again. And now my provider will pick up config maps coming from a kind cluster that is running on my local machine. And I could also start another kind cluster. It will dynamically be put into here, and then it will reconcile against two clusters. But this is how easy it was for me to switch from one provider to the other. And let's have a brief look at how complex that kind provider is, because the answer is not that much. So this is basically the gist of this provider. It is rating in a loop. It is listing the available kind clusters. It's doing some filtering on that. And then it goes through the process of creating a kube config, of eventually setting up a cache and a client, and basically remembering that. So that is one of the things that Stefan mentioned earlier. And that is really it. So this whole file with all the type definitions in the beginning, it's 200 lines. That's it. That's the provider. I'm done. So with that in mind, I think we're a bit slow on time.
Yeah, and we have a couple of providers as a prototype already in the repository, but nothing fancy. It's really POCs. So we have a cluster API here, the kind provider we just saw, some experimental namespace provider, and yeah, basically two trivial ones. One which has no cluster at all, one is just one cluster, super uninteresting. Our goal is not to have all the providers here, obviously, so a monorepo is an anti-pattern. So if you build something like a really serious cluster API provider, probably outside is a better place. We have the KCP provider, for example, here, so it's in KCP dev, multi-cluster runtime, and yeah, it implements what Marvin has just shown, uses virtual workspace API endpoint for exports, and yeah, that's the KCP one. Hopefully we get more, so if you have ideas, I'm looking at the cloud provider attendees here, would be interesting to run something against all clusters in your project or something like that. What is next? So we have many ideas. The experimental message here should eventually go away, I guess.
Yeah, exactly. So as we said, it's in the... I forgot. So yeah, so far this is an experiment, but of course we want to stabilize it and make it usable for everyone and basically hope that it gives you some value. So we have so many ideas. We don't have the time to talk about them. Maybe out of process providers, maybe as Stefan said, better providers, a cluster inventory provider for the Zig multi-cluster API, and go on. There's so many things to do. Next thing that we want to do is gather some experience with existing code bases. We have some patch sets with trying things out, but of course we would love to work with projects to see if they can gain value from adopting multi-cluster runtime, and also see if we're missing the mark, because this is something we want to build for the community, and you all know the XKCD comic. We hope to not create another standard, but something that is meaningful. So we need to hear from you if this is really what you need. Or if there's something, it's too simple, it's too complex, it misses the mark. So please tell us. And with that, thank you for listening. These are the QR codes for the repository, for the Zig multi-cluster select channel, and for rating this talk, whether you liked it or not. We'd love to hear your feedback. Thank you very much.
Thank you. So we have a few minutes for questions, if there are any.
And there's a microphone in the middle, if anyone wants to ask one.
I have a question. In probably your second, this is not a multi-cluster situation, if you remember. You have a central manager managing other clusters. Finally, what is different with this multi-cluster manager or multi-cluster controller? Because if I understand correctly, it's still living in one cluster, and it is able to reconcile all the clusters.
Yeah.
But it's still master or central. So it's like your management cluster you were illustrating, but different, I don't know.
So you can run multiple managers. This pattern works, it's totally valid. And for uniform controllers, you can do that, and people do it. What you get here is tighter integration, like the work queue, so you can better control what your pod is actually doing. If you have multiple managers, they're completely independent, right? They do their thing, and they use the resources as they want. You have no control over that.
Okay, so the network architecture is the same. You have one central management cluster with the multi-cluster controller, but just the fact it's Kubernetes native and integrated as a controller following all the patterns, the queues, all the things. It's the main difference, if I understand.
Not sure I understand.
The fact the multi-cluster controller is well integrated using the queues, as you said, and so maybe you understood something.
Well, I mean, so it's basically, what part of the controller you're scaling, right? So in the other examples, we had one manager, one queue, one source, one event handler, all of that, and you just, you scale at a different level. You have one manager, and you have one reconciler, and you have one work queue, but you're scaling in the middle, basically, because you can, start multiple sources. So I think that's just the difference in the scaling mechanism.
Okay.
Thank you guys for contributing this. This is really awesome, and I look forward to the integration with cluster profile provider on this SIG multi-cluster. The question for you would be around graduation from the experiment to GA. What do you see as the most important thing you want to tackle, and maybe a time frame for that?
I think the main input we need is the feedback that this works, like this model is the correct one. So we have some experiments taking existing bigger code bases and trying to implement that, but more of this kind would be helpful. So we have seen the other models which also exist and they are used. Does this bring value? That's the question basically. If we agree on the topology and it makes sense, then I think this is the bar.
Do we want to put a number on it, or? I don't know.
Oh no. The number of this implementation is like 3 weeks, 4 weeks since we started, basically, or since we made the project public. So it could be a matter of weeks, matter of the feedback we get here. So,
thank you.
A couple of questions, really quick one first. I didn't see the slides attached in the app. I don't know if that was a mistake with the app or if they've not been uploaded. But if not, do you plan to add the slides?
We'll add them, yeah.
Great, thanks. The main question then, is there support for heterogeneous providers? So if I've got multiple clusters, some on AWS, some on GCP, for example.
Yeah, I think you can just build a union provider and attach multiple of them. I mean, the interface you have seen, right? There's a getter and there's the index function, so it should be possible,
so yeah.
I guess. Yeah.
Cool, thank you.
Hi, I'm pretty excited about this project as someone who manages a relatively large, uncommonly large number of clusters in production, and I think this could really help us and help us also control costs, so I'm pretty excited about it. The main question I have for you guys is how to, how this is going to work with CRDs that might not be the same version in the various different clusters that are being managed.
Yeah, technically, with the exception of the KCP provider, this is different. But the providers we have shown here, there's one kubeconfig per cluster, so there's an informer behind the scenes, so one cache per cluster. And this will use a version of the specific cluster, so there is no difference. In your reconciler, you might have to distinguish, right? You will use Go types, and maybe there's an old or a new cluster. So you could imagine that you build some meta information into your provider you can query, and then you know which version is installed or something in this direction.
Okay. So within the reconcile loop, it would try to differentiate between the older version of the CRD and possibly a newer version. And, okay.
Well, you can ask the manager for the provider, you do some interface type check, whether it has this meta information interface, and then you ask which CRD, something in this direction will work.
Cool, thank you.
Thank you. So in the code walkthrough that Marvin was doing in a kind provider, right? I saw you were initializing indexes and caches yourself. Is that going to be responsibility of the provider as opposed to just providing?
That's a provider, yeah, because it differs by use case. I think there's one class of providers which basically provide kube configs, and then we could basically build a library which unifies that if you want to.
Yeah,
if that's the model you want to implement, yeah.
I mean, from a layering perspective, it sounds like the cluster providers would probably just provide you the kube config, right? And most everything else probably is common across all providers?
For most of them, yeah. Yeah. So we need something like a unified framework. I mean, framework is a big word here, I think, a package which does that. And the gPC topic, like the remote or out-of-process provider, maybe it just provides kube configs, as simple as that, and everything else is done in process.
And what's the position of the controller-runtime maintainers on merging the two?
I didn't mention that in this experimental message there was a link to the design in Controller-runtime, and it's a friendly extension. So Stefan is here, he proposed actually to try that. So maybe eventually it might move back when we agree on the shape of the thing. This is one possibility. If we need something more on Controller-runtime, I hope they are open to edit.
I agree.